Hi, this is Vivian Arana here, and today we are going to look at how to set up a blockchain network using Node.js. I've been getting a lot of requests on this after I wrote this article on Medium, and I realized that let's create a video for this. Now, to create a blockchain network using Node.js, you can use a library such as crypto.js, which will help you to create the cryptographic hashes for the blocks in your blockchain, and Express.js, which will help us to create the API for interacting with the blockchain. Now, you'll also need to implement the basic structure of a blockchain, which includes adding the validating blocks as well as maintaining the chain's integrity. Additionally, you can use libraries such as Web3.js to interact with the Ethereum blockchain. Now let's go over the steps briefly to create a basic blockchain network using using Node.js. The first step is to create a new Node.js project and install the necessary libraries, which are crypto.js, Express, and Web3.js. Next step is to define the structure of a block in your blockchain. Now each block should have a unique index, a timestamp, and the data that you want to store in the block. Next step is to create a blockchain class that can add new blocks to the chain and validate the integrity of the chain. Step 4 is to create an endpoint using Express.js that can be used to add new data to the blockchain. Step 5 will be to create another endpoint that can be used to retrieve the current state of the blockchain. In step 6, we will add functionality to the blockchain for maintaining the integrity of the chain, such as detecting and resolving conflicts between different versions of the chain. And the last step is use the Web3.js library to interact with Ethereum blockchain by connecting to an Ethereum node and deploying smart contracts. Now, this is again a high level overview of the process of creating a blockchain network using Node.js. There are many more details to consider, such as security and scalability, and you may want to consult more detailed resources or seek help from experienced developers, but I'm just going to go over the basic steps of this. Let's dive into step 1. So first, as I mentioned, we need to create a new Node.js project and install the necessary libraries, which are the crypto.js, Express, and Web3.js. Now first, create a new Node.js project by running the following command in your terminal. As I go along, you can follow along this or you can do it on your own. So first I'll go and say npm init and follow the prompts to set up your projects. Let me go through that. Next, I'm going to install the necessary libraries by running the following commands in my terminal. So to install crypto.js, I'll say npm install crypto-js. For Express, I'm going to say npm install Express. And for Web3.js, I'm going to go over and use npm install Web3. Now, once I'm done with this, next I'm going to import the libraries into my project by adding the following lines at the top of my JavaScript file. So first I'm going to say express, create a variable express and say require express. Next I'll say constant crypto and require crypto.js, and web3 require web3.js. Now create a new instance. Next what we're going to do is create a new instance of the web3 class, which will be which will allow us to interact with the Ethereum blockchain. Now to do that, I'll say web3 equal to new web3, new web3 dot providers dot http provider, and I'm gonna give my localhost URL, which is localhost 8545 is the port. 8545 is the port in here. Next, I'm going to create an instance of the Express application by calling constant app equal to Express. Next, I'm going to do is set up the server to listen on a specific port. So I'm going to use, in this particular case, port equal to 3000, and then app.listen, pass that port, and I'll write an anonymous function which will return back a console log saying server is running on this particular port. Now once I complete this, next step is to verify that my libraries are installed correctly and the server is running by running the command on node and the file name that you've given .js in my terminal, and check the terminal for the message saying server running on the port 3000. And as you can see here, it successfully ran that, and we have set up we had our basic setup for our blockchain using Node.js. Now you can now proceed to the next steps. which includes defining the structure of the block and creating that blockchain class that I spoke about. So this concludes our step 1. So next step, step 2, is to define the structure of the block in our blockchain. Now each block should have a unique index, a timestamp, and the data that you want to store in the block. So let's go over that and create that class. So I'm going to call it class block. I'm going to create a constructor in this with the following parameters which I mentioned above, which is unique index. The next is the timestamp, the data that I want to store in that block, and previous hash. Now this is hash for the previous block. Since in the first case it will be nothing, so I'm going to just redefine it as empty. And inside the constructor, I'm going to assign these values. This dot index equal to index, this dot timestamp equal to timestamp, this dot data equal to data, this dot previous hash equal to previous hash, and this dot hash is equal to this dot calculate hash is a function which will calculate hash for the uh, current block, and that function I'll define below here, calculate hash, and inside this function I will return crypto-sha256 and pass the index plus the previous hash plus timestamp and pass the data converted to string. So this will create my hash for the current block, which will be used by the next block. So this is step 2, and once you complete this, if you have any questions, leave me in the comments, but this is how you create a basic block structure. Let's look at step 3. Now in this step, what we're going to do is we're going to create that blockchain class that I spoke about earlier, that can add new blocks to the chain, and block was what we created in the previous step, and validate the integrity of the chain. Now let's start with class blockchain. I'm going to create a constructor. In this constructor, I'm going to set this dot chain equal to this dot create genesis block. I'll call that function. And now let's define this create genesis block function below. Return, and what this block does is it will return a new block with this is the genesis block, so I can define it as start. Now the index, I'll probably give it a 0. Timestamp, I'm going to give it today's date here, and call it the next part is the data, which I'm going to just call it genesis block as the data, text data, and the previous hash is 0 since there's no hash available. And next I'm going to create a get latest block function, and in this function I'm going to return this dot chain, and inside that I'll get this dot chain dot length of the chain and remove the index -1, and that's what this will give the latest block. So this dot chain length is going to give me the length of the entire chain, and remove 1 because arrays work in a way start from 0, so that's why I have to remove -1 from the length. Next, I'm going to define the add block function, where I'm going to pass the new block as the parameter. Now inside this function, first I'm going to assign the previous hash to the new block object as this dot get latest block dot hash, and then I'm going to assign new block dot hash equal to new block dot calculate hash. So this will calculate the hash for that new block. Next, I'm going to do is this dot chain dot push. So I'm going to pass pushing the new block to the current chain. So that's this add block function. Next, we need to check if the chain is valid. So for that, I'm going to create the is chain valid function. Now inside this, I'm going to write a for loop which will go from I equal to 1 to the chain dot length. So this dot chain dot length, and we'll go up till I plus plus, and inside the function, inside this particular for loop, we'll create a variable current block, which is this dot chain of I. So assign that value to this. Next, we'll create the previous block, which is this dot chain I -1. So the previous block is I -1. So we'll probably assign that here. Next, I'm going to look at if current block dot hash is not equal to current block dot calculate hash, to just to make sure that if it's valid or not. If it's not, I'm going to return false. Another check that I'll have to do is if current block dot previous hash is not equal to previous block dot hash, that is also an invalid uh, chain. So for both of these, as you see here, we are returning false. And then if none of these, for the entire loop, nothing, if it goes through properly, that means the chain is valid and will return true. So in the blockchain class here, the create genesis block method is used to create the first block in the blockchain, also known as the genesis block. The get latest block method returns the latest block in the blockchain. The add block method is used to add a new block to the blockchain, and the is chain valid method is used to validate the integrity of the blockchain by checking that the hashes of the blocks are correct, and then the previous hash of each block matches the hash of the previous block. This is like the basic structure for your blockchain network using Node.js. Now you can proceed to the next steps where we will be looking at creating endpoints for adding new data to the blockchain and also creating another endpoint for retrieving the current state of the blockchain. So this is it for step number 3. Next move to step 4. So step 4 is creating an endpoint using Express.js that can be used to add new data to the blockchain. So let's go and start creating this. So first I'll say app.use express.json. Let's create the blockchain variable and create a new blockchain using that blockchain class that we created earlier. And to create the post endpoint, I'll say app.post, and inside that I'll say the route is add data slash add data, and it will give me back an anonymous function which is has parameters request and response. And inside this I'll create a variable data which will be request dot body. Next I'll have new block variable which will create a block where say new block, create blockchain dot get latest block dot index plus one. So whatever the index of the previous block is, I get the latest block and then take its index and increment that by one. We'll give the current timestamps, a new date, and pass the data along with it. And this is how we create a new block. Now I'll say blockchain, the variable that we created above, we'll say add block and pass this new block to it. So when it's created, this new block will be added as a part of that blockchain. And then once this has been added, we'll probably send back a response with status code 200 and say the text data added successfully. So this is the actual code for it. Now in this, the endpoint is listening for a post request on the slash add data route. When a request is received, the data from the request body is stored in the new block and added to the blockchain using the add block method. That's what we saw. And the response is sent back to the client confirming that the data was added. Now let's go to the step 5 where we are going to create another endpoint that can be used to retrieve the current state of the blockchain. So let's go and add that. In this, what we're going to do is we're going to create an app.get request, and the route will be slash get chain. And when the request is received, so anonymous function, and we'll pass the entire blockchain is returned as the response. So that is by response the status code of 200, and we'll send blockchain dot chain. So we'll send the entire chain back. Now this is a basic implementation of adding and retrieving data from a blockchain network using Node.js and Express.js. You can next what we'll do is we'll proceed to the steps where we adding more functionality to blockchain for maintaining the integrity of the chain, such as detecting and resolving conflicts between different versions of the chain. So in step 6, what we're going to do is we're going to add the functionality to the blockchain for maintaining the integrity of the chain, such as I mentioned, detecting uh, conflicts and resolving them when there's different versions of the particular chain. Now, to do this, let's go over some of the steps. So first is so to add this functionality, what we have to do is to the blockchain for maintaining this integrity, you can implement the consensus algorithm. Now let's go over let's look at some of the consensus algorithm. The consensus algorithm is a mechanism that allows nodes in a distributed system to come to an agreement on the current state of the chain. So some of the popular consensus algorithm include the proof of work (POW). In POW, miners must solve a complex mathematical puzzle in order to add a new block to the chain. Now the first miner to solve the puzzle gets to add the block and is rewarded with a certain number of cryptocurrency coins. Now, this helps to prevent malicious actors from tampering within the blockchain. The next algorithm is the proof of stake, which is POS. In POS, the probability of a node being chosen to add a new block to the chain is proportional to the amount of cryptocurrency coins that the node holds. Now, this helps to prevent malicious actors from tampering with the blockchain. The next algorithm is the delegated proof of stake, which is DPoS. In DPoS, nodes are elected as delegates to represent the interests of the community. The delegates are responsible for adding new blocks to the chain and are rewarded with cryptocurrency coins. Also, the last one that we'll look at is the practical Byzantine fault tolerance (PBFT). In PBFT, nodes must reach a consensus by exchanging messages. PBFT is suitable for permission blockchain where nodes have known identities. Now, by implementing a consensus algorithm, you can ensure that all the nodes in the network are in agreement on the current state of the chain, and that any conflicts are detected and resolved in a timely manner. Now, you can also use other techniques like creating a fork choice rule for resolving forks in the chain, use a mechanism for peer-to-peer communication between nodes in the network, and adding a mechanism for digital signature and encryption to secure transactions on the blockchain, which will help to maintain the integrity of the chain. Now, let's look at an example on how we might use the crypto.js to implement a simple proof of work consensus algorithm. Now, first is what we'll do is we'll create a function that takes in the current block and target difficulty and a target difficulty level and returns a valid hash for the block that meets the difficulty level. Now, in this, we'll create a function mine block and pass it two parameters, block and difficulty. Now, inside the function, we will create a while loop which will go over the check if block dot hash dot substring with 0 comma difficulty if it's not equal to array of difficulty plus 1 join to 0. So it will go through until this is not equal and increment the nonce by 1 by I can do that by block dot nonce plus plus, and then hash I'll say SHA-256, pass the block dot index plus timestamp plus data plus nonce and convert that to string. So here, once I do that, once I've complete this, this is the block. It will keep on going it until it finds that if the not equal to is kind of met, the condition is met, and then once that is done, I'll just say console.log block mined and pass the block hash as in the log. Now in this example, as you can see, the mine block function uses the SHA-256 algorithm from crypto.js to calculate the hash of the block. It then repeatedly increments the nonce, which is a random number, and recalculates the hash until a valid hash is found that meets the difficulty level. Now you can use the mine block function in your add block method to mine a new block before adding it to the blockchain. When the add block, you can say mine block and pass the new block and this dot difficulty, and next step you can do is this dot chain dot push and push the new block to it. So you can actually mine the block before you add it instead of creating it yourself. Now this is a basic example on how to implement the proof of work consensus algorithm in Node.js using the crypto.js library. Keep in mind this is a simplified example, and in practice there are many more complexities and considerations to take into account when building a real world blockchain system, but this kind of gets you started on that. You can also use libraries like Bitcoin, Bitcoin.js library, which provides a lot of functionalities that are required to build a blockchain network, like creating a new block, creating transaction, creating wallet, signing the transaction, and more stuff. Additionally, you can use other libraries like Web3.js for Ethereum-based blockchain network and Hyperledger Fabric SDK node for building a permission blockchain network. You can also use blockchain frameworks like Ethereum, Hyperledger, or EOSIO that provides a lot of functionalities out of the box and also have their own consensus algorithm. In short, you can just use the all these above mentioned whatever libraries I mentioned and framework to implement the consensus algorithm in Node.js, but you should carefully choose the one that fits your case, because they do different things. So based on your requirement, you can use that. Now, next step is to use the Web3 JS library to interact with the Ethereum blockchain by connecting to an Ethereum node and deploying smart contracts. So Web3 JS library is a JavaScript library that allows you to interact with the Ethereum blockchain by connecting to Ethereum node. Some of the steps that we use, some of the steps to use the Web3 library to interact with Ethereum blockchain are: first, you install the Web3.js library by running that npm install web3 in the terminal. I think we already did that. Next, connect to the Ethereum node by creating an instance of the Web3 class. For example, you can connect to a local Ethereum node running on the default port 8545 by doing the following. You can say that, like here, I can create a web3 object as I require, and then web3 create a new web3 instance and pass the uh, local host with 8545 where it's running. Now, to deploy smart contracts, you'll need to have a contracts bytecode and ABI, which is the application binary interface ready. You can get them from Solidity compiler or from the contract developer. Now, next, you can deploy the smart contract by creating a new instance of the contract object and then calling the deploy method on that instance, passing in the bytecode and the ABI as argument. For example, let's do this. Let's go over this. So first, I'm going to create a constant contract and say new web3 dot ethereum, which is eth dot contract, and pass ABI to it. Next, once you're done with that, you deploy the contract by calling contract.deploy, and inside this we'll pass the data.bytecode, the data which is the bytecode, and then the functions that will these can call a send. So from a particular address, that address of account that is deploying the contract, and how much gas this is required. So I'll probably say, let's say I'll give around 4.7 million gas. And then function is new contract instance, and inside this I'm going to say console.log new contract instance dot options dot address. So this what this complete. So this is an example of how you can deploy a particular contract. Now, once the smart contract is deployed, you can interact with it by calling its methods and viewing its state using the contract object you created. For example, you can call a method named get on the contract, something like this. Let's say contract.methods.get.call, and then console.log. So this is how you can call it. To make a transaction, you'll need to sign the transaction and send it to the network. You can use Web3 ETH accounts sign transaction for signing the transaction, and Web3 ETH send signed transaction to for sending the signed transaction to the network. So let's look at that. 3 ETH account signed transaction, and the parameters are 2 data gas and gas price, and also the private key of the account signing the transaction. Now, for data, what we'll do is let's say address to a particular contract. I'll just give that data. I'll give contract.methods.set gas and gas price values, random numbers. I'm just going to give it, and of course the private key. And then once it's done, I'll say then signed is web3 send signed transaction. Pass the signed row transaction to it. Once I'm done with that, I'll console.log. Now, it is important to note that you will need a sufficient amount of ether in the account you are using to deploy the smart contract and make these transactions. Now, the gas price should also be set accordingly to the current gas prices on the Ethereum network. Now, in summary, the Web3 library allows you to interact with Ethereum blockchain by connecting to the Ethereum node, deploying smart contracts and making transactions. Now you can use the Web3 ETH contract class to create instances of smart contracts, deploy them, and interact with them by calling their methods and viewing their states. If you have more questions on this, this is the completed basic version of it. There's more things that you can add, but this is just a basic setup of blockchain network using Node.js. I hope it helps. If you have any questions, just add it to the comments below. Thank you for watching again.